Our next speaker will be Kristen Jenkins from Atkins, North America. She'll be speaking about the use of in situ fluorometrics to identify seasonal spatial variations in chlorophyll patterns in the Lower Peach River Upper Charlotte Harbor system.
I'll just preface this by saying that this is actually Ralph Montgomery's presentation that he put together on behalf of the Petersburg, Minnesota Regional Water Supply Authority. Ralph, unfortunately for all of you, could not be here today, so we're stuck with me presenting this on his behalf. I managed an analogous project for Atkins for Tampa Water and Tampa Estuary, so hopefully that costs enough knowledge to relay what he intended to be related for the Petersburg system. Can everybody hear me okay?
A little louder.
A little louder, okay. So let me just start with an overview of the Peace River Hydrobiological Monitoring Program, or HBMP. We'll talk about a couple different components of that, as well as a more recent addition to the program, which began in April of last year, which is the focus of the talk, an in situ transect water quality monitoring program. The monitoring program on the Peace River has been around since 1976 and has included both fixed water quality monitoring sites, which are shown in the green dots as well as the red triangles. At all stations, vertical water column profiles are taken, and at the spots indicated by the green dots, bottom and surface water chemistry samples are taken as well. In addition to the fixed monitoring, there's also an isohaline-based monitoring program, which in theory transects this 30-kilometer stretch of the river, but starting at river kilometer 0 here. However, you actually can end up going negative kilometers down to the harbor out here. What happens on these isohaline-based monitoring is they go out and look for the first occurrence of each of these 4 isohaline listed here. And this occurs on a monthly basis, as does the fixed monitoring. So in addition to the monthly monitoring that occurs, there are a series of continuous recorder monitoring sites along the transect of the monitoring area from the Peace River. And these include both USGS monitoring sites indicated by the green arrows on this map, as well as authority-owned equipment. There are 8 authority sites indicated by the red arrows. And these range from downstream below the I-75 bridge all the way up to just past the intake of the water treatment facility. And data are recorded in 15-minute intervals that include temperature, conductivity. USGS gauge is also on this page. And this is a map of the existing array as it stood in 2012. I believe it's still the same today. There hasn't always been an equal number of sites that you see on this map. And while it's a relatively newer component to the program, it has become one of the most fundamental parts of the monitoring program. It provides a high level of both spatial and temporal data for salinity, conductivity, and temperature. My slides just did not change. These data can be used to look at seasonal spatial shifts in conductivity, looking for relationships with flow. And then these observed data can be used to build statistical models, which can then be used to predict the potential magnitude and duration of salinity changes that may be due to facility withdrawals and affect the change in flow. And this is what the stations in general look like. We've got a stilling well at the sonde, sonde placed with a float on it, so they're floating surface for the authority-owned on various pilings, trestles along the Peace River. Okay, so this shows the range of data that were collected in the span of 1 year. This was 2012 for all of the USGS and authority-owned And you can see this is the most downstream station here. You have quite a range in salinity. And then here on this end being just near the intake for the water treatment facility. While in general for most of the year are quite low, you can actually reach a fairly high connectivity salinity value at certain times of the year. This is the same map again, just to show that there's two stars on here, so that subsequent graphs will show a more detailed time series for 2012 for each of those locations. The first came downstream at that river kilometer 9.2. As you can see, salinity is typically high, except that during the wet season it can become quite brackish to near fresh, quite far down in the system. And this is the station just above at the intake for the water treatment facility. Generally fresh, except that during the dry season, when flows are low, you can actually get fairly high conductivity salinity. And even though flows are low to the point where they're below the authority's ability to draw, even if they could, conductivities are such that they may not be able to use the water or they able to take it. So, putting together the idea of flows and the input of nutrients and changes in residence time, you incorporate all these things into the development of a chlorophyll maxima. So Ralph and the authority were interested in looking at how these chlorophyll maxima might be influenced by changes in flow in the Peace River system. So they began this spatially intense transect sampling for chlorophyll that occurs monthly. And this is just a picture of the basic setup. There are two peristaltic pumps that are connected to provide flow into a chamber where there are two YSI multi-parameter sondes, and all of this is connected to a GPS. The transects occur monthly, and they occur on the same day as the fixed station sampling occurs. And transects always begin at river kilometer 0, and they move at the same speed every time, which is regulated by the GPS. And measurements are recorded every 1 minute. So this is a constant flow through that chamber using those sondes to measure a variety of parameters. And the entire transect is traversed each day. So the equipment includes 5 optical sensors for CROM, blue grains, chlorophyll, and turbidity. At the same time, temperature, specific conductance, salinity, and pH are recorded. They also record DO, but it's not typically used because it's through a flow-through chamber, perhaps not accurate. And along this transect, occasionally graph samples for color and chlorophyll are taken for calibration purposes. And that occurs every day, so each run provides an independent model. Okay, so I mentioned that the sampling began in 2013, and Ralph included this just to show the range of flow relative to other years. This is daily gauge flow upstream of the facility. And 2013 was a fairly average year, following a few years after perhaps a relatively dry period. And this is just a close-up of the last 2010 through 2013. And 2013 did have a prolonged wet season. Okay, so each of the transects can provide the ability to have a spatially intensive plot or map of the daily. So the three maps up here include salinity, color, and chlorophyll. And all of these are color-coded for the range. So the colors that are light green are relatively low values, ranging up to the reds and purples, which would be relatively high on a given scale. values showed that water was fairly brackish all the way down to the harbor. Color, Ralph called this relatively low. I guess I'm not just working on the piece, but these range from 138 to 270 in values, and color increases as you work your way upstream. This is on the descending limb of the flow, so just coming down from a lot of rain, washing input into the river. So color values are still somewhat elevated in the upper regions. And chlorophyll exhibits potentially two maxima. The center area here, which Ralph told me has been identified as a key area in the estuary for productivity, particularly in the spring, as well as this downward area here towards the harbor. So what Ralph did was just put together the first 9 months of data collected from April to December of 2013. There's a series of maps like this for each of them. So these are going to be just chlorophyll from here on out. On the left will be the data collected on that day. So the range, in this case, it's from less than 3 to 28 to 30. That's the range that was observed on that day. And on the right will be a historical harbor distribution. So while if you were to look at the graph on the left, the map on the left, it looks like there is the maximum occurs, there's a peak up in the upper section. But when you look at that in historical context, those values are not high in the relative sense. So as we move into May, you can see that on a relative scale that maxima is becoming more intense. And as we move into June, there's been some rain and things are sort of shifting down the system. Flow has picked up a bit. And in July, you've had a lot of rain and things are pretty much, the system is flushed. There's not enough residence time for the flows to occur. Everything is flushed down the system. And where you might have a localized peak is down in the harbor, but even in the valleys where we're calling a peak, it's 10 to 11 on this left-hand map, which is not even showing up in the sense of the historical value. Same thing in August, we still got some high flows, and then these are the same ones from September where you're starting to have declining flows. Peaks move back up from the harbor further up towards the upper regions, and this continues on into October. By November, you've got the peaks in that central and upstream regions again, and similarly in December. So this was really just meant to provide a general overview of a recent addition to the program. This is intended to run for 3 years. It will be collected monthly. Once all of the data is collected, Ralph's intent is to look at potential relationships between chlorophyll and flow, both between the abundance of chlorophyll and probably more likely the location of the center of abundance. And at the very least, if you can get some kind of relationship, you can maybe have some information on health of the harbor. But if you can end up with a strong relationship between either a center of abundance or an actual abundance and flow, then you can take this a step further and start looking at any potential influence of changes in flow, i.e. withdrawals to chlorophyll in the base river estuary.
We certainly have time for questions. Anybody like to sit to the microphone?
I saw something like this that I think your company did for the Ohio River.
Yes.
Really cool model. And I think there was a correction factor, like people who do discrete sampling of chlorophyll with this set of numbers, and these numbers are different, and that they're just measured differently. Is there a correction factor in this process?
These are all 400 values that are measured in Situ, what I have. Now, I mentioned there are grass samples that are taken along. Usually it occurs when you see a shift. You're watching things as they progress down the transect, and you see, oh my goodness, it's obviously shifted into a different batch of marks. Take a grass sample. Then those grass samples are run for each individual sampling day, used to calibrate a model for that day. So it calibrates what the photosynthetic values were versus what the laboratory chlorophyll values were. So that actually sample water is used to corroborate and calibrate the values read by the software.
Can I ask another question? The three estuary programs in Southwest Florida are working on a tidal creek study. And part of that, the way I perceive it at least, is not productivity. We call this a peak of productivity or something to threads. Do you think this type of approach has a lot of value for understanding the hundreds of creek systems? And more pointedly, does it identify places where restoration would do the most benefit?
Well, I think there would definitely be potential for that. This methodology is not perfect, but neither is what's been used in the past, and then as you go out and take as many residents as you can afford, basically locations where you can get your might changes. So you're always potentially missing signals in between where your drive signals occur. So these continuous transits allow you to have much finer scale of resolution. Sacrifice a little bit because you don't have the temporal into one day, and then how frequently you do that. Because of the finer scale that you get, you may have the ability to answer finer scale questions, such as, but the problem is that you need to have enough of them to identify spatial and seasonal effects, and it changes.
And is there a relationship to either protection or restoration or stormwater benefits?
I mean, if you know, as we touched on, and Kelly touched on, like it's they're complicated issues, right? You've got chlorophyll, influenced by color, influenced by turbidity, influenced by residence time, which is influenced by flushing rate flow. So I think that there's definitely potential. I think we're at the point now where we're still assessing what the overall value will be and how it can be used elsewhere.
Thank you.
Can I ask one question?
Do you have any idea about how to use the model for larger scale changes in inflows or outflows, either related to major land use changes or climate?
I'm sorry, I didn't quite catch the last part.
Either the larger scale hydrologic changes that might affect the flows of the salinities and whatever that might be related to land use changes or climate changes.
Well, I think actually where we are right now is that it's better suited for the larger picture issues. And until we've collected more data and formulated more of a kind of relationship between flow in general, we actually don't have enough right now to move into the finer scale to ask the very small questions of how much did this relatively small change from a withdrawal affect the movement. So larger scale issues, if it's done on a regular basis, like I said, you can end up having this Charlotte Harbor thing where you can look over time, you run the same transits over